Reaction energy. All reactions involve energy. Some reactions need an input of energy. Some reactions give off energy. Most reactions need a little bit of energy to start the reaction. We will use a potential energy diagram to show the changes in energy related to the reaction. E sub A is the activation energy. This is the amount of energy that must be put in to get a reaction started. Delta E is the reaction energy. This is the net amount of energy that was lost or gained during the reaction. That's right over here. In this case, the energy of the products is less than the energy of the reactants, so the reaction is exothermic. And here's our potential energy on the y-axis, and here's our reaction progressing through time, reactants, products. In this case, the energy of the products, right, goes over there to the potential energy, is more than the energy of the reactants, so the reaction is endothermic. In some places, delta E is written as delta H. This is because the energy released or added to the reaction is in the form of heat. This chart summarizes the main points for endothermic and exothermic reactions. And here's a little mnemonic on the first row here. Endothermic, heat enters the system, En for endothermic. For exothermic, heat exits the system, Ex, Ex. So for endothermic, the reaction feels cold. The heat leaves your hand and enters into the reaction system. Exothermic, reaction feels warm. The heat leaves the reaction system and you feel it with your hand. Endothermic, products have more potential energy than reactants. Exothermic, just the opposite. The reactant has more potential energy than the products. Endothermic state changes include melting and vaporization. Exothermic state changes include freezing and condensation.